Hello everybody and welcome to another mystery box function challenge. In the purple box there is some mystery math and your challenge is to figure out what that is. You can use the link in the description, try out as many numbers as you like, and when you've got an idea, come on back and see if we get the same thing. Okay, let's start with a 0. Oh, so 0 gives us, well, a negative infinity. Okay, so that's an error. It doesn't, there is no value of negative infinity that it reaches at 0, but it approaches that value. Okay, so that's an odd one. Let's try a negative number. I was suspicion that maybe we had a curve that was reaching down to the y along the y-axis as an asymptote, and then isn't on the negative side of the graph. Let's just put in another negative number to double check that. Looks like we're not cool in the negatives. Let's try some positives. So let's put in a 1. And 1 gives us 0. Okay, I've got some inklings now. Let's put in a 2. Let's put in a 3. Okay. So I'm going to give some fractional values here. So let's put in a 1/2. All right, and maybe a 1/4. And maybe 1/10. All right, so we've got a curve here that stretches down towards negative infinity along the y-axis and then kind of gets a little more shallow and continues out in this way. To me, this looks like a logarithmic function. So we should think about that. And then this point 1, 0 is a key for that too. Logs are can be tricky to wrap your head around. So let's think about logs for a minute. So when you've got an exponential expression like a, whoops, let me get my pen going here. So a to the power of b equals some number c. The way that we express that as a log is it's the log base a. So a is the base and b is the exponent. And so the log base a of some number is going to give you the power. So for example, if I had 10 to the second power, that would equal 100. The way we'd express that is that it would be the log base 10 of 100 is 2. So the log of some number is giving you that power that you raise this base to get that result. So that can be a little tricky. It's kind of a turn, flips around our thinking here. The point 1, 0 makes sense for any logarithmic function, because whatever the base is, if you raise it to 0, so I'm just going to make a note here, this is our power. If you raise it to 0, you're going to get 1, because anything to the 0 power is 1. The question is, what's the base of this log? Um, so, and what we'd want to do actually is look where the power is 1. And we didn't get that exactly, but it's somewhere, let's see, somewhere in here, right? So somewhere between 2 and 3. Our base is between 2 and 3. That's a little odd. Unless you happen to know about the number e and the natural log. So I think this is just the natural log of x, and that's because that number e is 2 point something. It's between 2 and 3, and the natural log is base e. So the natural log of x really is the log base e of some number. So let's try putting an approximation for e. Let's see how close we can get. I'm going to put in a 2.7. We're trying to get close to 1. Ooh, so that's almost there, 0.99. Let's put in a 2.8. Now we're just a little bit over. So it's somewhere between 2.7 and 2.8 and gives us that value of 1. Putting in these two approximations here, this has clinched it for me. I think this is just the natural log of x. So it looks like Any other logarithmic function, it's just that where it gives a value of 1 is at the number e, which is somewhere between 2.7 and 2.8. So I think we're going to call it there. Let's go ahead and reveal this. Yeah, this is f of x equals the natural log of x, and we can graph that as well. And you see that typical logarithmic shape crossing at the point 1, 0, but also at this point e comma 1. Well, how did that go for you? I think this was a super difficult one unless you happen to know about the number e and the natural log of x. Let me know. Thanks, everybody.